Hello everyone, you're welcome back to my class. This is a continuation of our JAMB practice session. In our last class, we practiced 2025 past question, and we stopped at question 10. We're going to continue from question 11 today. So 11 says, a thermometer has a scale that is linear with the resistance of a wire. The resistance of the wire is 50 ohms at the ice point, 0 degrees Celsius, and 90 ohms at the steam point, which is 100 degrees Celsius. What is the temperature when the resistance is 70 ohms? So in this type of question, you draw the first one, which should be the temperature scale in degrees Celsius, and the other one, the temperature scale in that is resistance thermometer, right? So here is the 100 degrees Celsius, this upper scale, and here is the 0 degrees Celsius, the ice point. And according to the question, the resistance thermometer has 50 ohms at the ice point. So you locate it here at the ice point, we have 50 ohms. And the 90 ohms at the steam point. So you trace it back to the steam point and you have your 90 ohms. What is the temperature when the resistance is 70 ohms? So when the resistance thermometer increase to around 70, let's assume here is 70 ohms. So what is the corresponding temperature in a degree Celsius? So you trace it to this point and you let it be T degrees Celsius. So this is the first approach. So the next thing you do here is to take a proportion. So taking proportion. So this temperature minus lowest fixed temperature, that is T minus 0 all over the upper fixed point. You're taking it with respect to what? To the respect with the steam point, the ice point. That is 100 minus 0 should be equal to the same way you took T minus 0, so it will be 70 minus 50. I have 70 minus 50, all divided by 90 minus 50. So I have here to be 90 minus 50. So T minus 0 gives us T all over 100 minus 0 give us 100. That would be equal to 70 minus 50. That will give us 20 all over 90 minus 50. That will give us 40. So here we cross multiply. When you cross multiply, you're going to have 40 multiplied by T, have 40 multiplied by T equal to 100 multiplied by 20. So that will give us 40T equal to what? 2,000. Is that correct? So that T will be equal to, divide both sides by 40. That is 2,000 divided by 40. 0 cancel 0. I'll be left with 200 divided by 4. That will be equal to 4 here, 1. 4 in 20, that will give us 5. We have our answer to be 40 degrees Celsius. So the correct answer here is 50 degrees Celsius rather. Correct answer here is option C. So that is about question number 11. So moving on to question 12. So question 12 says, a wave pulse is sent down a string that is fixed at one end. When the pulse reaches the fixed end, it will be A, reflected and inverted, B, not reflected and absorbed, C, reflected but not inverted, D, reflected and its speed increased. So this is how it looks like. A pulse is sent down a string that is fixed at one end. So we have a fix, maybe here is a fixed position, and here is the string, and it fixed another place here, right? So when you disturb this string now, it's going to form a wave like this. So this is the incident. This is the incident. On reaching this place, it will form the reflected wave will be in this format. So the reflected wave will be in this format. You can see it's inverted. So this one was like this, and this is like this. So that is inverted. So it's going to be reflect, right? And inverted. So the correct option is option A. So that's about question 12. Question 13. Question 13 says, a 2 kg block is attached to a string and swung in a vertical cycle of radius 0.5 meter. What is the minimum speed of the block at the top of the cycle to ensure the string remains taut, given that g is 9.8 meter per second squared? So solution, given that the mass is 2 kg, is that correct? And the radius r is said to be 0.5 meter. So what is the minimum speed? V is not given, that's what we're looking for. And g is given to be equal to 9.8 meter per second squared. So there's a condition to this question that what is the minimum speed of the block at the top of the cycle to ensure the string remain taut, right? So in order to ensure this, remember when the body is performing a circular motion, here is the body at a distance r from the center, right? And here is the tangential velocity, which is v. So we have a centripetal force, which is the force that keep the object in a circular path. So in order for this, this is the string, in order for it to remain taut, for the object to be in a circular path, there must be a balance force, right? And that is the force that keeps, there must be a force that balances the centripetal force for that to be in a continuous circular motion. This time around, it will be balanced by the weight of this particular body, right? So the centripetal force must be equal to the weight of the body, which is what? The mass times acceleration due to gravity of that body. So what is centripetal force? Centripetal force mathematically is represented as mv squared all over r. Yes, I think you are correct. Yes, mv squared over r, that will be equal to mg. So if this is done, mass will cancel mass, so we'll be left with what? V squared all over r equal to g. So from here, we have we can make our v subject to the formula. So we have v squared will be equal to r multiplied by g, so that our v will be equal to the square root of r multiplied by g. So that would be r is given to be 0.5 multiplied by g, which is 9.8. Then we are going to have the square root of 0.5 multiplied by 9.8. That should give us a 4.9. That is 4.9. So when you press your calculator, you're going to have square root of 4.9 to give us a 2.21 meter per second. So that is option B. That is option B. I hope this is understood. So that's about this question 13. Question 14 says, a block with an initial speed of 10 meters per second slide on a horizontal surface and comes to rest after traveling a distance of 25 meters. What is the coefficient of kinetic friction between the block and the surface? So there's no much difference between the coefficient of kinetic friction and that of static friction. So static friction, you know, it is the force that needed to be overcome, right? Just before an object starts moving. Why the kinetic friction is the opposition given to the body that is already in motion, right? So they all have the same formula that the mu for static is the frictional force or limiting frictional force all over the normal reaction. This one has this one. And also mu for kinetic is Fm, the moving force all over the normal reaction as well. I hope this is understood. So let's start from what we have here. We have a block with an initial velocity slide on a horizontal surface. So let's assume here is our horizontal surface, right? Here's our horizontal surface, and this is the object that slides on this horizontal. It's not static, it's already in motion, right? The body is already in motion. And there's no application, there's no force applying to it, pushing it on this surface. It's already pushed, it's already in motion. So the frictional force we are talking about now is the kinetic friction, right? Good. So as it is in this case, it now come to rest. On getting to this particular point, after a certain time, it now come to rest. So when it comes to rest here, we have our final velocity to be equal to 0 meter per second. The initial speed, right, is u, which is said to be 10 meter per second. So there's an unbalanced force. Remember, unbalanced force causes motion, and unbalanced force also causes motion, which is acceleration. It also causes a deceleration, right? So the only unbalanced force that exists here, right, is as a result of the friction. It's as a result of the kinetic friction, which is the only unbalanced force that is acting opposite to the direction of the motion of the body. So that's the only unbalanced force. And that unbalanced force is given to be equal to mass times what? Acceleration. So the unbalanced force here is equal to what? The kinetic friction. Is that clear? So we have, which is equal to mass times acceleration. Is that understood? So we don't have the acceleration, but we can get our acceleration from these equations of motion. That is v squared equal to u squared plus 2as. Is that clear? So initial velocity is 0 is equal to final velocity is 0, initial velocity is 10, so you have 10 squared plus 2 multiplied by the acceleration. This is a deceleration rather, because it comes to rest. So multiplied by the distance, which is said to be 25 meter. Is that clear? So from here I have 0 equal to 100 plus what? 2 times 25, that will give us 58. So when this come to this the other side, that will be 0 minus 100 equal to what? Minus equal to 58. So that I have minus 100 equal to 58. So from here, I have 50a equal to minus 100, which is the same. So divide both sides by 50. Divide both sides by 50. I have a to be equal to minus 2 meter per second square, which is my deceleration. You can see deceleration is a negative of acceleration because the body comes to a rest. So now from here, I can get I can get, what is it? The moving force, which is the unbalanced force that causes the deceleration, and that will be MA, right? MA equal to, which is equal to the moving force, right? M is equal to moving force. You can leave it like this. But remember that the coefficient of static friction, kinetic friction is equal to Fm all over what? The normal reaction. Is that clear? So we can say Fm now is equal to what? Mu R, right? Mu K multiplied by normal reaction. Is that clear? So anywhere we see Fm, we put what? Ma equal to the coefficient of kinetic friction multiplied by R is something as mg. Is that correct? So that mass, we cancel mass. Then our A, we now have A equal to mu K, right? Mu K multiplied by G. So that what is our A? Our A is -2 equal to mu K times what? Times G, which is 10. Let's not go with the negative. The negative shows a sense of deceleration. So that mu K now will be, divide both sides by 10, divide both sides by 10, this by 10. This implies that mu K is equal to 2 divided by 10. That will give us mu K to be equal to 0.2. I hope this is understood. So that is about question 14. Question 14. So moving on to question 15. Question 15 says, why does a person perceive a metal surface to feel colder than a wooden surface, even when both are at the same temperature? So this is under heat transfer, thermal conductivity. The metal has a higher thermal conductivity than the wood. B, the metal has a higher specific capacity than the wood. C, the metal has a higher temperature than the wood, despite reading the same on a thermometer. D, the metal radiates more heat than the wood. So the correct answer is option A. The metal has better thermal conductivity. It conducts the heat away quickly, and it now the temperature now fall and therefore become colder than the wooden, who has a lower thermal conductivity. So the correct answer here is option A. So moving on to question 16. Question 16 said a uniform U-tube initially contains water in both arms. Oil with a density of 800 kilogram per meter cube is poured into the left arm until the oil column reaches a height of 0.25 meter. What is the height of the water column in the right arm relative to the original water level? Taking density of water to be 1000 kilogram per meter cube. So solution. So let's quickly draw our U-tube. So we have something like this. It might not be perfect. So we have something like this. Let's manage this one. So here is our U-tube. And let's assume, according to the question, initially we have water poured into it. So here should be our water. We assume it will be of the same level. Here is water. So now we introduce oil into this. And when this happens, so we have oil introduced into the left arm. So let's call this left arm, and here is right arm. So introduce oil. So it is expected that the water here will be pushed up, right? So water here will be pushed up to a certain level, so which should be here, right? So it was initially here until, and the height given to us for the water, for the oil, please follow me gently. until the height of the oil is said to be 0.25 meter. So it is expected that the water level will also be pushed up. So when this happens, we asked to calculate the height of the water corresponding to the initial water level. So here is going to be H water. Is that understood? As simple as this. So, according to the characteristic of liquid, the pressure in liquid, unlike solid, the pressure in liquid is the same at all levels, right? So the pressure exerted by this oil here, right, P of the oil will be equal to the pressure due to the column of water, right? Pressure due to the column of water here, you have P water. So pressure due to the column of oil will be equal to pressure due to the column of what? Of water. And here, the pressure is the density of the water, of the oil, multiplied by the acceleration due to gravity, multiplied by the height of the oil. This will be equal to density of water multiplied by acceleration due to gravity, multiplied by what? By the height of the water. Is that understood? So since G is the same, it can cancel each other. I can now have rho of oil, height of oil, equal to density of water, then height of water. Sorry, here is water. So when this is done, we can now since we're looking for the height of water, we make height of the water subject to the formula. So we have height of the water will be equal to the density of oil multiplied by height of oil all over the density of water. So from there, we are going to have density of oil is said to be 800 multiplied by the height of oil, which is 0.25, then all divided by the density of water, which is 1,000. I hope this is understood. So from here, what will be 800 multiplied by 0.25? That should give us 200. That should give us 200, all divided by 1,000. So this one will go with this one. That will give us 2 all over 10, which is equal to 0.2 what? 0.2 meter. I hope this is understood. So that is about question 15. So moving on, that our answer is option C. Yes. So moving on to question 16. That's about question 16, right? So we are going to question 17 now. Question 17 says, which of the following pairs represent one scalar, and one vector quantity respectively, meaning that scalar will come first, right? Followed by what? Vector. So let's look at that. In our option A, this is a scalar and this is also a scalar. So this option is gone. Here is a scalar and here is a vector. We might consider it. Here is a scalar, here is also a scalar. It is gone. And here is a force, which is vector come first, and temperature scalar. This one is also good, but they say respectively. So scalar must come first. And the only option that has that is the option B, scalar speed followed by what? Velocity. Is that understood? So that is about question 17. Moving on to question 18. Which of the following statements correctly describe the gravitational potential near a massive object? A, it is maximum, least negative at the surface of the object. B, it is zero at an infinite distance from the object. And what? C, it becomes less negative as the distance from the object decreases. And D, it is it is a vector quantity. This one is automatically out of it because gravitational potential is a scalar quantity. Remember, gravitational potential is given to be equal to minus G M all over R. So remember that G is a constant, so we will be considering the mass of the object and the distance. So the more massive the object and the more smaller the distance become, right? The more it becomes negative or closer to zero. So here now, as the distance R is or tend to infinity, right? Then what will happen to the gravitational potential? It will be closing or more closer to what? To 0. Residual potential will be what? 10 to be 10 to 0. Is that understood? So the correct option here is that it is 0 at infinite distance from the object. So that is option B. I hope we are together. So move to question 19. Question 19 says, a uniform beam PQ 10 meter long and of mass 20 kg is supported at both ends, right? A mass of 40 grams is suspended at a 0.4 meter from end P. Find the reaction at the support P and Q, taking G to be 10 meters per second squared. Okay. So when you have this type of question, the first thing to do is to draw this assumption. We assume, right? Here is our meter rule. And according to the question, the meter rule is 10 meter. So meaning that from here to this point is 10 meter. That's the length of the meter rule. So it's 10 meter. Is that understood? So a uniform beam is uniform. 10 meter is PQ. So here is my P and P, and here is and what? Q. So of mass 20 grams. So the mass of this meter is 20 grams. And remember that of center of gravity. Center of gravity is the point where the entire mass or entire weight of an object tend to lie, isn't it? Or tend to concentrate. So since this particular meter rule is 20 grams, that is where the mass or the weight lies, is going to be at the center. So we assume here is the center. That's where the mass of that particular meter rule is going to lie. So let's say here is the mass of the meter rule. So remember, our work is in Newton, so and they give us gram, have to convert it. So it's going to be 20 times 10. That will give us what? That will give us 200 Newton here. Remember, weight is equal to mg. So they give us mass of 20 multiplied by 10 because we asked to take it to be 10. That will give us what? 200 Newton. Please take note. That's why I have 200 Newton here. Now, moving on. They now say that a mass of 40 grams is suspended at a 0.4 meter from one end. Now, before we move on, since the mass lies at the center and the whole meter rule is 10 meters, therefore, from this place to this place will give us what? 5 meters. I hope I'm making sense. Give us 5 meters. So from here to here also is a 5 meters. Is that clear? Good. So a 40 kg is suspended at a 0.4 meter from, so if we are from P, I'm going like this, right? Going like this, okay, 4 meters. Let's assume if from here to here is 5 meters, then we assume that this point must be 4 meters. So they say from, so meaning that from this place, that is where we have our 4 meters. Is that correct? So if from here to here is 5 meters and from here to here is 4 meters, what will be from this point? This point will be what? 1 meter. So that has been sorted out. I hope we are together. So when you are done, they now said from end P, find the reaction at the support P and Q. So there must be a support here, our pivot, right? So there must be a support here. So we are looking for the reaction at this support. So that is here should be 40 grams. That will be 400 Newton. Remember what I've just done here. Convert it to Newton by multiplying 40 by 10, give us 400 Newton. That has been done, and here our support. So the support, the reaction on the support P, we call it ROP, and the reaction on the support Q, we call it a RQ. So we're asked to find the reaction here, ROP and ROQ. That's what the question asks us to do. So for us to achieve this, we now say, okay, taking moment about any of the pivot or any of the support. Taking moment about support, let's say support P. taking moment about support P, meaning that all our thing will be referring it to the support. Is that understood? But before we do that, we look at the principle of moment, which say that the sum of the upward force equal to sum of the downward force. So sum of the upward forces equal to sum of the downward forces. So the upward forces are the normal reactions, that is RP plus, right, RQ. The downward forces are this one. These are the downward forces, that is 400 plus 200. So this implies that RP plus RQ will be equal to 600. Please take note of this one. Okay. If that has been done, we now come back to taking moment about support P, meaning that we'll be referring all our movement, taking moment here, the reaction of support P will be fixed. So we'll be taking this, multiply the reaction, this force, multiplied by the entire distance, right, to this point, to this pivot. So we're going to have, remember, before we do that, I forgot something. Another principle of moment, which is a clockwise moment is equal to anti-clockwise moment. You know that the clockwise moment equal to what? Anti-clockwise moment. So this implies, what is our clockwise moment? Here is a face of clock for better understanding, right? So any moment you take in this direction, right? If you get going like this, that is clockwise. The actual moment of what? Of clock. So if you are going like this, is clockwise direction, clockwise. So if you take something in reverse, if you are coming like this, right, that is what? Anti-clockwise. So this is anti-clockwise moment. Is that understood with this example? So having known that, it shows that anything we do, we are going like this, that is what? Anti-clockwise. This is anti-clockwise. So here is anti-clockwise direction. So if we go like this toward P, or this force toward P, that is a clockwise. So we are going like this clockwise, we are coming like this anti-clockwise. Is that understood? So our clockwise moment will be moment we take from this force 200 down to this is clockwise. Another one is this one to this is a clockwise. So we're going to have our clockwise moment is 2, that is 200 multiplied by the distance from this point to this pivot, which is total of 5, multiplied by 5, plus another force, which is in the same direction as the force 200 Newton, which is 400 Newton, is also clockwise. Remember what I told you about clockwise. Here, see my marker, that is clockwise. If I go like this, this is anti-clockwise. So now clockwise, that is 400 multiplied by the distance from here to this point, which is 4, multiplied by 4, is equal to anti-clockwise. What's my anti-clockwise? The only anti-clockwise I have is this one that is coming like this. This is anti-clockwise. So that's going to be RQ multiplied by the distance from this point to this, which is the whole of 10 meter. So it's going to be 10. So when you're done with that, you multiply this, that will give us, if you multiply 200 by 5, that will give us 1,000. So we have 1,000 plus 400 multiplied by 4, that will give us 1,600 equal to 10 RQ. This implies 10 RQ is equal to 1,000 plus 1,600, that will give us 2,600. 2,600, therefore RQ will be equal to 2,600 all divided by 10, which will give us 260 Newton. So the value of the reaction at support Q is 200 Newton. So when you have known this one, the next thing to do is to use this formula here, knowing fully well that RP plus RQ is equal to 600. And RP now plus RQ is given to be 260. We have founded it to be 260 equal to 600. Therefore, this implies that RP, the rational support P, will be equal to 600 minus 260. That will give us 340. 340 Newton. So these are our answer. Then we'll go forward and check the options. So P 340 and Q is 360. That will give us option D. Please, I would like you to go through this question and be acquainted with it. They are very simple. It's because I am teaching. That's why it takes time like this. If it is normal exam proper, all you need to do is to notify this plus this will be equal to this plus this, which I've done here. You take moment about any particular part, what you take the moment, then and you sort it out. I've done a particular video concerning detailed solution about equilibrium of forces. You can watch that and get acquainted with the questions. So now let's move to the last question for this section, which is question 20. So question 20 says, the least count of a vernier caliper is 0.01 centimeter. What does this imply? A, it can measure up to 1 meter. B, it can measure the smallest object. C, it can measure length up to 0.01 centimeter. D, it can measure with a precision of 0.01 centimeter. So the least count of vernier caliper to be 0.01 centimeter simply means that this is the smallest, right? This is the smallest measurement it can take. So the correct answer here is that it can measure with a precision of 0.01 centimeter. That's the accuracy of the vernier caliper. Are we together? So that's about question 20, which is option D. And I think we're going to stop here today in this session and continue from here in our next class. I hope you enjoyed the class. Should you have any problem or any question pertaining to most of the solution, please let me know in the comment section. I'll take it from there. Thank you for your time. See you in the next class.